Hi all, here we have a question to discuss, that is how many minimum number of bits are required to represent a decimal number -1 using signed magnitude, 1's complement and 2's complement representations. Here the word minimum is important. Let us discuss signed magnitude representation first. In signed magnitude representation, the range of decimal numbers that can be represented using n digits is from negative extreme -2 power n -1 to positive 2 power n -1 decimal. Here n is the number of digits used. To represent a -1 decimal, you can equate -2 power n -1 base 10 to a -1 decimal. That implies 2 power n -1 equal to 1 implies 2 power n -1 equal to 2. That implies n -1 equal to 1, that implies n equal to 2. Hence, 2 digits are required to represent a -1 decimal in signed magnitude representation. Let us see how to represent a -1 decimal using signed magnitude representation. Here, 1 bit MSB is dedicated for signed bit. The remaining n-1 digits represent the magnitude. Hence, 1 base 2 is corresponding to a minus number whose magnitude binary. That implies -1 decimal. Hence, a -1 is represented by a pattern 1 base 2. Let us discuss about the other patterns. Let us say 0 representation in signed magnitude, 1 representation signed magnitude, and 1 representation in signed magnitude. 0 implies MSB 0 number is positive and its magnitude is LSB, that is 0. That implies positive 0. 1 implies number is positive, magnitude is 1. Base 2 implies positive 1 decimal. And the last case, 10 base 2 implies number is negative because MSB is 1 and its magnitude is 0 base 2. That implies -0 decimal. Right? So a -0 and a +0 is represented by 10 and 00 patterns in signed magnitude representation. Right, so number of digits required to represent a -1, minimum number of digits required to represent a -1 is nothing but n equal to 2. Let us discuss 1's complement representation. 1's complement representation. Similar to signed magnitude representation, the range of decimal numbers that can be represented using n digits in 1's complement representation is nothing but -2 power n -1 decimal to positive extreme value positive 2 power n -1 decimal. To represent a -1, you can equate -2 power n -1 base 10 to -1 base 10 to identify minimum required value of n. That implies 2 power n -1 equal to 1. That implies n equal to 2. Hence, 2 digits are required to represent a -1 decimal in 1's complement representation. Let us see how to represent a -1 in 1's complement representation. To represent a -1 in 1's complement representation, let us take the magnitude of 1. That will give me 1 decimal. So to represent a -1 decimal, I should take the complement of the value of 1 in binary, that is 1 0 base 2. So that implies MSB is 1, number is negative. and while arriving the magnitude I should take the respective complement, 1's complement here, so I should take 0 1, so it is nothing but minus 1 decimal. Hence a minus 1 is represented by using the pattern 1 0 base 2. Let us take other patterns also, 0 0 0 1 and 1 1. 0 0 is a positive number, so its value will be positive. I should not take the complement while arriving the magnitude, that is a positive 0 decimal. 0 1 also a positive number because MSB is positive. Its magnitude is nothing but 0 1 itself. I should not take the complement. Its value is positive 1 decimal. Whereas 1 1 the number is negative. I should take the respective complement before arriving the magnitude. So 1 1 will become 0 0, that's equal to minus 0 decimal, right? Please note that to represent a plus 0 decimal we require only one digit, 0 itself. Number is positive, so one digit is required to represent a positive 0, right? The other case, if you are using single digit as 1, that will give me a negative number. Its value magnitude will be complement of that 0, that will give me minus 0 decimal. So to represent a positive 0 and a negative 0 in 1's complement representation, we require only one digit. Let us discuss 2's complement representation. 2's complement representation. In 2's complement representation, the range of decimal numbers that can be represented is from minus to power n minus 1 decimal. So to represent a minus 1 decimal in 2's complement representation, you can equate minus 2 power n minus 1 decimal to a minus 1 decimal. That implies 2 power n minus 1 equal to 1. That implies n minus 1 equal to 0. That implies n equal to 1. So a single digit is required to represent a minus 1 in 2's complement representation. Let us see what will be the represented value if the representation is 0 in 2's complement. 0 represented in 2's complement using single digit is nothing but number will be positive and its value will be 0 itself. So a plus 0 can be represented using one digit. Let us see the representation of minus 1 using one digit. 1 base 2 implies the number is negative. While arriving the magnitude, I should take the 2's complement of my 1, that is 1 itself. 1's complement plus 1, 1 itself, that will give me a minus 1 decimal. Hence to represent a minus 1 or to represent a positive 0, I require only one digit. So let us see how to represent a plus 1 in 2's complement representation. To represent a plus 1, I require 2 digits and the representation is 0 1 base 2. That implies MSB is 1, number is positive. I should not take the complement, so its magnitude is 0 1 itself base 2. That will give me positive 1 decimal. Right, so minus 1 can be represented using single digit 1. If you are extending that sign bit 1 1, then also the number will be negative. 2's complement of 1 1 is nothing but 1 0. So minus 1. If you are extending sign bit once again 111, the number is again negative. The value will be 2's complement. 2's complement of 111 is nothing but 001. So it is minus 1 itself. If you are extending once more 4 1's, then also the number is negative. Its magnitude is 2's complement of 1111, that is 0001. So all these represents a minus 1 decimal. In general, if you are extending the sign bit, the represented number won't change. So effectively, only one digit is required to represent a minus 1 in 2's complement representation. 2 digits are required to represent a minus 1 in 1's complement representation, and 2 digits are required to represent a minus 1 in signed magnitude representation.